Hi, good day. Welcome in today's lesson. I am Teacher Marisol, your math buddy, and I will be here to help you in developing your logical reasoning and critical thinking skills. Today, you will learn how to transform quadratic functions from standard form to vertex form. But first, let us have a quick review of your factoring pattern, especially in a perfect square trinomial. Can you still remember the factor of a perfect square trinomial? These are examples of a perfect square trinomial. Notice that the first and the last terms are perfect squares. The middle term is plus minus twice the product of the square root of the first and the last term. What is the factor of a perfect square trinomial? The factor of a perfect square trinomial is a square of a binomial. So how is a perfect square trinomial and a square of a binomial related to our lesson on transforming quadratic functions from standard form to vertex form? How do you transform quadratic functions from standard form into vertex form? Observe these functions. Notice that the first function is in a standard form y equals ax squared plus bx plus c, while the second is in a vertex form y equals a times x minus h squared plus k, where your hk is the vertex of the quadratic function. This is important especially in graphing the quadratic function and getting its turning point. Let us analyze this vertex form. Observe that x minus h squared is a square of a binomial. So from our standard form y equals ax squared plus bx plus c, we have to create a perfect square trinomial from this equation so that its factor is a square of a binomial. Now, let us try to transform some quadratic functions from standard form to vertex form. We have three functions here. We will transform them from this form to this form. The first step that we need to do is to create a perfect square trinomial. So we need to make sure that our a is equal to 1. Observe the three functions. So in the first function, we can say that a is already equal to 1. So we can just write it as x squared plus 4x minus 5. On our second function, we have a negative. So a is equal to negative 1. What we're gonna do is to factor that out of the first two terms. That is, y equals negative 1 times x squared minus 6x plus 11. Now our a is equal to 1. So we're all set. On the third function, we have to factor out a 5. That is y equals 5 times x squared plus 2x plus 1. Now we can get the terms inside the parentheses and create a perfect square trinomial. So we have the last terms as our missing terms. So, what we do now is to complete the square. We can find c, or the missing term, by dividing b, the numerical coefficient of our second term, by 2. After dividing by 2, square your answer. So in our first function, b is equal to 4. And 4 divided by 2 is 2. Square of 2 is 4. In our second function, b is equal to negative 6. Divided by 2, that is negative 3. Square of negative 3 is 9. On the last function, b is 2. So 2 divided by 2 is 1. Square of 1 is 1. So these are the values that complete the perfect squares. Now, let us try to add them to our first two terms to create a perfect square trinomial. That is, y equals x squared plus 4x plus 4 minus 5. Y equals negative 1 times x squared minus 6x plus 9 plus 11. Y equals 5 times x squared plus 2x plus 1 plus 1. Now in the properties of equality, we are used to add or subtract values on both the right side and the left side of our equation. But in here, we are purely working only on the right side of the equation. we don't need anymore to transpose it to the other side. What we only need to do is, since the values were added to create a perfect square trinomial, we are now going to subtract them to our constant outside the parentheses. So in our first function, when we added 4 inside the parentheses, we now subtract 4 outside the parentheses. Now in our second function, we added 9 inside the parentheses, but notice that 9 is being multiplied to -1. So we have to subtract 9 times -1 outside the parentheses. On our third and last function, we added 1. So we need to subtract 1 times 5. Now, let us simplify first the terms outside the parentheses. That is, y equals x squared plus 4x plus 4 minus 9. Y equals -1 times x squared minus 6x plus 9 plus 20. Y equals 5 times x squared plus 2x plus 1 minus 4. So now, it's time to factor out our perfect square trinomial to form a square of a binomial. Only perfect square trinomial has the factor that is square of a binomial. So on our first function, what two numbers that are exactly the same value that when multiplied will give us 4 and then add to give us 4? We can say that our final values can be 2. So our function is y equals x plus 2 squared minus 9. Now, we have taken this function already from standard form to vertex form. What about the second function? What exactly the same two numbers that when multiplied will give us 9 and add to give us -6? The answer is -3. So our function now is y equals negative the quantity x minus 3 squared plus 20. On the last function, what could be the two exact number when multiplied will give us 1 and 2 as their sum? That is equal to +1. So our function is y equals 5 times x plus 1 squared minus 4. So there you go, learners. That is how to transform quadratic functions from standard form into vertex form. What are the important things to keep in mind when transforming quadratic functions from standard form into vertex form? First, your a must be equal to 1. If not, factor out a. Second, create a perfect square trinomial by completing the square. That is, solve for the value of the last term of the perfect square trinomial. Third, add or subtract the value that was added or subtracted inside the parentheses to the constant outside the parentheses. Fourth, simplify the terms outside the parentheses. Fifth, and lastly, factor the perfect square trinomial. This step might be too long, but it is very important and proper to use. There is also another way in finding the vertex of our quadratic function, that is, using the formula. So we have the vertex formula here, where h is equal to -b over 2a and k equals 4ac minus b squared over 4a. Let's apply these formulas. Let's try to express y equals 3x squared minus 12x plus 16 in vertex form. First, we need to find the value of our a, b, and c. So our a is 3, b is -12, and c is 16. So we now solve for our h and k. Since our h is equal to -b over 2a, our h is 2. And our k is equal to 4ac minus b squared over 4a, then our k is 4. The values of h and k are 2 and 4 respectively. Substituting them to the vertex form, y equals a times x minus h squared plus k, we obtain y equals 3 times x minus 2 squared plus 4. If we want to transform it again the other way, from vertex form to standard form, the steps are very simple. For example, given the function y equals x plus 6 squared minus 4, transform this function into standard form. Just expand the binomial square and simplify the function. That is, x plus 6 squared is equal to x plus 6 times x plus 6. And that will be equal to x squared plus 12x plus 36. Now we have y equals x squared plus 12x plus 36 minus 4. Simplifying, that will be y equals x squared plus 12x plus 32. So that's it, learners. This is very simple. Congratulations for a job well done. I hope you've learned a lot in today's lesson. And that concludes our lesson for today. For the next lesson, you are going to graph a quadratic function. And again, this is your teacher Marisol. Bear in mind that learning math is and will always be fun. Keep safe and have a nice day!